Bismillahirrahmanirrahim. Today I wanted to present a model that I have made some time ago, but I was unable to prepare the lecture because I wanted to simplify the model to make it easy to understand, and didn't manage to complete the process. I will discuss some things about this. Alright, we have discussed all of these issues in different places. What I wanted to say is that the process of modeling, building models to understand the world, is sort of essential and central to constructing any good theories and to understanding the world. This process is not well explained or understood in your economics textbooks. So basically the reality is very complex. A model is a simple picture of it. The model exists in mind space. It's a theoretical object. It is not a real object. And the process of modeling, you go back and forth. It's always it's like a generalization. You make a law of some sort that throughout history such and such has happened. So then you have to go and examine in concrete details what this law means in real life. And then you go back from the understanding of the particular to the general. So this is true in all cases. You have to think at two levels simultaneously. You have to think about the law, and then you have to think about the application. So for example, if you look at a quadratic equation and you want to solve, then you can say, okay, it's ax squared plus bx plus c equals 0, and the roots are x plus equals minus b plus or minus square root of b squared minus 4ac divided by 2a. So that's the general principle. Then you have to translate this to, okay, here's an equation. It is 3x squared plus 5x plus 7 equals 0, and then you calculate the roots, and then you see that when you put in the values of x into the equation, it comes out to 0. So on the one hand you have the general law, and then you have the special application. And unless you understand at both levels, you don't get understanding. So this is a complicated process that you need to learn. The same is true in everything. And in economics, when you have supply and demand theory, okay, there's this theory, there's the curve, and there's the other curve, and there's the equilibrium. Then you have to understand how it applies to the real world. So you have to think about general mathematical laws, then you have to see how it works in the real world, and then after you look at how it works in the real world, then you might have to go back and modify the law to take care of the And then after modifying the law, you come back to the real world and see if the modification works, and so on. So this is the process. Unfortunately, in your economics textbooks, they never follow this process. They just create the theory and they never discuss how it applies in the real world. So, I wanted to look at, basically, as I said, in the supply and demand theory, the central problem is that the theory itself is not coherent. It makes contradictory assumptions. It's self-contradictory because if the price is determined by the equilibrium of supply and demand, then the price is endogenous. And once the price is endogenous, then the question is, how do you calculate the supply function? So you calculate the supply function by assuming that the price is exogenous and it varies, and then you ask how the supply changes. So this, if the price is exogenous, it can't be endogenous, and vice versa. So I have resolved this problem in this model that I wanted to present, but by saying that, all right, the supply will be provided by the village and the demand will be in the city. So for the village people, this is a sort of we assume that through historical process there is some price in the city which is prevalent. So the village is small, it doesn't affect the price. So people in the farm know what the price is, and then they grow the wheat that they are producing. Then what happens is that if the price is then the first question which arises is that how do we solve for the supply function? Yes. So if we take one small farm, right, so we have this general idea that, okay, I'm going to talk about production functions and I'm going to talk about demand in the city. I'm going to take demand pretty much as the standard classical demand, so it's going to be a linear demand function where as the supply increases, the quantity demanded decreases. As the price increases, the quantity demanded decreases. So I'm going to take a standard type of a production function. Now, actually, I've worked in the class with fixed proportion production function, and this leads to results which are very different from classical, because basically the marginal productivity of labor in that case is constant up until a certain point, and then it suddenly falls to zero if you have fixed proportions, because you cannot equate marginal productivity to wage, because it can only take two values and it doesn't take any value in the middle. So if the wage is in the middle, then you have problems. But since I want to construct an argument against the standard theory, so it's better for me to take a production function which is along their lines, even though it doesn't really make a lot of sense. Here we are talking about a Cobb-Douglas production function. So the production function, I use the letter T for land. T is for terra, because if I use L, that would be labor. So a standard Cobb-Douglas function has the form T to the 1 minus A, L to the A. So now you see we are translating the general principle to a very special. I mean, you have to do the calculations as well. You can't do economics by just doing philosophy. But it doesn't mean that you I mean, both things have to be done at the same time. You have to do the philosophy to understand what we are trying to do, and then you have to do the calculations to see how it works out. So both parts are necessary simultaneously. So now the reason that this t to the 1 minus al to the a is not a very pleasant function is that it means that you can substitute land for labor. This doesn't really seem plausible when you're growing corn, that if I have a smaller amount of land, I can make up for it by adding more labor. It seems that both are essential inputs, and if you have less land, you can't produce more food by replacing land by labor. But but if you do what I did, which is to take a fixed proportion production function, then basically the total supply of wheat that is available from the village, it gets fixed at a particular amount. And if the production is profitable, then everybody will produce. And when the production is not profitable, then nobody will produce. So you have a 1-0 on-off switch. Now in this situation, the standard idea that the market adjusts the supply to demand, this is not possible. So what happens in this situation is that either you have excess supply or you have undersupply, and there is no equilibrium. So many things happen which are very unpleasant to the standard supply and demand theory. And so I wanted to show that this same thing works even if you use the standard economist assumption. That is, the model doesn't really make sense. The supply and demand model doesn't really make sense. So I said, okay, let's concede as much as we can. So let us concede the Cobb-Douglas production function, even though it doesn't really make sense. So see, what happens is that we're trying to maximize profits. Now, the thing is that the standard economic theory says that the firm can maximize profits on their own without knowing what anybody else is doing. But actually, you see, now I'm trying to plant my crops today, and I want to maximize profits. So what do I need? I need to know what the price of wheat will be tomorrow when the wheat is produced. Now that is something that is not observable. And see, this is what I mean about thinking about the concrete and the particular simultaneously with the general law. Okay, is this really true in the real world? Well, I met some people who have these chickens that they raise for poultry farms. So they know their costs. They have to buy feed and they have to buy medicine. Actually, these things are also quite random. Sometimes the chickens get sick and then you have to buy extra vaccines, and sometimes they just die. So actually, at the time that you're planting, you don't know exactly what the output will be. So that's another problem with maximization. But let's suppose that we ignore that. The thing is that you don't know what the price of chicken will be at the time that your chickens are ready to be sold in the market. So you guess, and sometimes there are major mistakes in the guessing, because for some reasons. So at the time that you're planting the crop, you don't know. I mean, currently, for example, suppose there's scarcity in the tomato market. Say, okay, let's plant some tomatoes to take because they are earning a huge profit. But suppose that everybody else gets this same idea. So by the time your tomatoes become ripe, then there's a glut in the market. So this is very realistic. So how can you maximize profits when? So there are two things. You don't know what the price will be tomorrow when you take your produce to the market, and you don't know what anybody else is doing. So suppose that we buy completely the supply and demand market, that okay, the amount of supplied will determine the price, demand curve being fixed let's assume. So then the price that will prevail in the market tomorrow depends on the total supply that will be taking place tomorrow. Now the total supply that takes place tomorrow is not subject to my decision. It depends on what I'm thinking about how much to grow and what thousands of other people are thinking. And how the thousands of other people are going to behave is not known to me. So how can I maximize profits? The function has values which are unknown and unpredictable. Unpredictable for two reasons. One is that it depends on decisions of others, which I cannot tell. This is the kind of thing that you have studied in your models of duopoly and oligopoly, where economists solve these models by making artificial assumptions. But let's drop these artificial, let's use our brains, something which economists don't like to do. Suppose that you are really in an oligopoly. Then I'm going to say, okay, I declare that this is Stackelberg, and so, no, this is not how it works. In the real world, suppose we are in an oligopoly. So what's happening is that there are a few producers, so the amount that everyone produces has an effect on the marketplace. Now what I need to know in order to make my decision is, how are the other people going to decide? Not so much how the other people are going to decide as what they are going to produce. Because the total amount produced is going to determine the price. That's the basic issue of oligopoly, as opposed to the competitive equilibrium. The competitive equilibrium, it is assumed that my contribution is small, so it's not going to affect the aggregate output, so it's not going to have a big effect on the price. Now, this is true that a small amount will only have a small effect on price. But what is not clear is, so you see the aggregate supply is, let's say, Q star, which is what other people produce, plus Q, which is what I am going to produce. So what I am going to produce is not going to have much effect on price. So I can treat prices as being fixed and determined by Q star, which is what the others are going to produce. But what are the others going to produce? This is something I don't know. So basically, what the others are going to produce will determine the market price, but the market price is what I am supposed to take as given. So basically the function that I am supposed to maximize depends on things that I don't know, which means that I can't maximize. So what's the result? There are two very important results. One is that people's expectations matter. This is something which has been discovered over and over again and suppressed over and over again, because this really makes people sort of free. In fact, this is what one of the key insights of Keynes, which has been suppressed completely in the literature, is that the future of the economy depends on our expectations. And he says that the investors, see, I'm going to invest in the economy, I'm going to build a factory. So now, should I build a factory or not? Well, that depends on what I think will happen in the future. Will there be a demand for the product? Well, if the economy is prospering, then there will be a demand. And if the economy is not prospering, then there will not be a demand. So my decision to build a factory depends on whether I am optimistic about what is going to happen in the future or whether I am pessimistic. Now, is there a way that I can forecast? Now, this is exactly what the economists make a mistake about. They think that the trajectory of the economy is deterministic. They don't want to have people in the economy. They want to have robots. Because people can think, and this is what Keynes said, that the investor's opinion is not tied to any real factors. It's just wild. Investors can say, okay, everybody can be optimistic, and they can say, okay, let's build. And this will actually have a positive impact on the economy. So the economy changes for no physical reason. Suddenly everybody decides that, okay, we are excited. This is called, there is a book by the title Irrational Exuberance by Robert Shiller. Why does the stock market boom? Well, because everybody thinks that it's going to boom. That's all. There is no real drivers. This is something which is very unpleasant for economic theory, because economists like to believe that everything has a cause. Now, if it's just that everybody becomes cheerful and optimistic and there is no change in real factors, then suddenly the stock market starts booming, the investments start increasing. This is very strange now, because no regression is going to predict this, because this is all in the minds of the people. But this is exactly what happens really in the real world. And so this is, coming back to supply and demand, we have this problem that expectations matter. And so now, if we're not going to have profit maximizing, because profit maximizing just is impossible, you can't do it, because the function that you want to maximize has parameters that are not known. So you have to replace those parameters by expectations. So that's one very important lesson. The second important lesson is that maximization is not possible, so one has to do something else. So what is that something else? What people do is they follow rules of behavior. So then what we do is we program these rules. And so this is what the agent-based modeling methods are useful for. Let me tell you a story about, there is a paper which is very famous, you have heard of it, the Durbin-Watson Statistic. This was written in 1950s or 60s. So why the Durbin-Watson paper was, for the next 30 years, the most cited paper of in all of econometrics, and it is still very high in the list, though citations have come down. So why was it the most popular, paper? Well, because around that time people were running these time series regressions, and they learned that autocorrelation is a serious problem, and it often occurs, and they were looking for ways to test for autocorrelation. But the problem was that any test that you would devise would depend on the matrix of regressors, the distribution. So if you want to find critical values, here's my test. Does this test statistic accept the null hypothesis or does it reject? In order to find out, I have to know what the critical value is. In order to find the critical value depends on the regressors. Now remember that the regressors is a T by K matrix, which is a lot of numbers. All of the data go into determining the critical value. What does that mean? It means that if you want to calculate the critical value, you have to do it for every data set separately. You cannot make a table of critical values. There were no computers. This is the key word. There were no computers. So what Durbin and Watson did was they found an upper bound and a lower bound which all matrices would satisfy. So then they made a table of values. So now people could test for autocorrelation and time series regression was the most popular thing, using the tables that Durbin and Watson had made. And these tables were such that every matrix of regressors, regardless of what it was bounded above by this upper value and it was bounded below by this lower value. So you could find out, to within some range of ambiguity, whether your test rejects or whether it accepts. So this made it possible to test for autocorrelation because there were no computers. Now today we can calculate the exact critical value for any table of regressors. We just feed it to the computer and it produces the number. Today the Durbin-Watson paper would not have been publishable because it does some things which are not needed anymore. We can calculate the critical values. We don't need, in fact, the upper bound and lower bound useless because we can calculate the exact critical value. So the paper is completely useless today. Now, the thing is, to a much greater extent than you realize, economic theories that we are making, we are studying today, are constrained by the ability of the economist to do calculations. They make theories like the Cobb-Douglas function, production function, because you can do the calculation, you can differentiate it. If you look at real-world production functions, and people have done so, they are extremely complex, non-linear. I mean, you can go and study how the technology, what happens is that things change very rapidly if you are employing a lot of, like even in the farm, you see, if you are employing on 1 acre, you want to employ 1,000 laborers, then you have to completely change the methodology, way of thinking, technology about farming. If you're employing one laborer, then you will be doing something else. I mean, you will be producing other outputs. I mean, if you have only one laborer, you will think of producing something else, and if you have 1,000 laborers, you will think of doing something else. So everything, and even the product that you're making will change. So there are very so it won't be subject to calculus. So basically, the theories that we are studying are governed by the capabilities of the economists to do calculations with pencil and paper. And so if we say, all right, we have computers, then suddenly all of the theory will change, because the theory was developed because you could only do these calculations. See, for example, today the statistical books, they teach you that the measure of central tendency of the data is the mean. You take the average of all the numbers, and this is the... Now it turns out that this theory was developed when there were no computers. So what people did was they said, okay, what should we use as a measure of central tendency? And they said that it turns out that if you have the data is normally distributed, then you can reduce it to two numbers, the mean and the standard deviation. And basically that captures all of the information that there is in the data, if the data is normal. If the data is not normal, then it cannot be reduced to two numbers. Then you have to look at the whole thing. So if you have 1,000-point data set, then you have to look at all the 1,000 numbers. And we can't do that without a computer. Therefore, what happened was that people assumed that all data is normal. And all of the modern statistical textbooks are based on the assumption that data is going to be normal. And then they teach you that you should look at the mean and you should look at the standard deviation. Now, more recently, when we have got the computer and we have studied data sets, we have found that most data sets are not normal. And one of the very interesting findings is that the mean, which is the best description of the data when the data is normal, is the worst description of data when the data is not normal. So, if we start by if we have an arbitrary data set we don't know anything about, and I say what is a measure of central tendency, then we should use the median. This is the best. If you don't know anything, then median is a good place to start from. And the mean is the worst place. There is a technical reason for saying that mean is the worst. Basically, there is something called the breakdown value. And the breakdown value measures what percentage of the data needs to be contaminated in order to throw your measure completely off. So we say that, okay, I have 1,000 points of data. I will give 1 point of data to some enemy who wants to deceive me. How much damage can he do? Well, if you're using the mean, he can do anything he likes, because by moving it to plus infinity, the mean will become plus infinity. If he moves that 1 point to minus infinity, the mean will become minus infinity. As opposed to this, if I'm using the median, if my enemy has 1 point of data, there's not much he can do to me. So my data doesn't, the median doesn't break down with the even. So what I want to say is that if the history of statistics was not that it was invented at a time when there were no computers, we would not be studying mean and standard deviation in the textbooks today. Exactly like this, the material that you are studying in the textbooks of economics is based on the limited capabilities that the economists have to solve equations. The theories that you are studying are adapted to the equations which can be solved by hand. Now suppose we just chuck that in the garbage and we say that we want to study theories which can be solved by the computer. Then we will be studying an entirely different type of theory. And this is what I would like to teach you, because now these methods are available and they can be used, and they are very strongly resisted by economists because basically it challenges their expertise. So now when we build agent-based models, one of the key things that comes in is how do we model expectations? How do farmers decide on how much crop to plant today? Now this is something you cannot figure out by doing calculations, mathematical calculations on pencil and paper. To answer this question, you have to go to the farmer and ask, how do you decide whether you're going to plant rice or cotton or wheat, and do you think about what the price will be? And so when you go and ask people, this is very special, then you will create hypotheses about how models should look like. Then you will be able to put in the correct assumptions about what the agents do, and then you can put in 1,000 agents and you can give them different types of expectations. That okay, some people believe this and some people do this, and these are the rules they follow. And then you can run the system that ask the computer, okay, we have 1,000 agents and they think like this, what is going to happen? And then you let the computer calculate, because you cannot, and the economists cannot calculate what will happen. But now we have computers. So what happens is that so expectations matter. Equilibrium will typically not arise. The assumptions of competitive equilibrium that we see are not valid. The ideas that there is perfect information and zero transaction cost, this is not valid. So in this model which I was going to present, we consider, for example, that, I think I have a picture here. Okay, so here's a demand function for wheat. Here's a supply and demand. So in this supply and demand function, we have 600 units of wheat being supplied to the city, and 60 is the equilibrium price. So suppose that we have 600 farmers, each of them produce 1 unit of wheat, and they take it to the city. And now, technically, we know that in the past, the 60, at the price of 60, the market clears, right? So everybody is charging 60 rupees because they know that at this price everybody will be able to sell. But suppose that one of the farmers is a little bit smart, sharp, or maybe stubborn. He says, I won't charge 60, I'll charge 61 rupees. So now, according to economic theory, everybody immediately gets all this information, and they immediately leave him. They say, we won't buy from you, and they have magic transport, and they can go to other place, and they get, okay, so all of this happens magically. This is the magic of markets. But now the problem is that there are only 599 other units, and there are 600 buyers. So this 599 are bought, and this person is going, where is this 60 rupee wheat? Sorry, it's sold. Sorry, it's sold. Sorry, it's sold. He's going magically to all the 599, and it's all sold. Now there's only this one farmer. He says that, look, you're not supposed to sell at 61 because the equilibrium price is 60. He says that, I'm sorry, I'm just selling it at 61. So what's this guy going to do? Now, if you look at the supply and demand curve story, you will see that nearly all of the demanders have surplus. They have consumer surplus. They are willing to buy, not exactly. There's only one buyer who is exactly indifferent at 60. Anybody who is willing to buy at less than 60, they are out of the market. But there are 600 buyers. One of these buyers is exactly at 60. And if he has not bought, then this person is out of luck. Then he will say, I'm sorry, I will not buy at 61. But if it's any of the other 599, they are willing to buy. And so they will say, okay, I will take it for 61. You Shylock, you Jew, why are you charging? You are unfair. You are charging higher price than equilibrium. But he will buy it because he has no choice. Now, next round, something can happen. You see, this idea that, you see what the economist says is that, okay, the cost of production being what it is, and you can make profits at 60, so suddenly someone else will come from the village, oh, I've produced this good, and now you can buy it. That's ridiculous. It won't happen. Next round, which may be 1 year from now, people will say, oh, somebody managed to sell for 61, so maybe we should also try to sell for 61. And so, if next year 2 people try, and in fact I tried this, and this, I found that, you see, what I did, I was going to show you the calculations, because actually, you see, I'm just doing philosophy here, and you need to do both. You need to do the exact, precise calculations, which I have done, but unfortunately I couldn't make up the presentation. Maybe I have it here. So anyway, what I did was, here it is. Suppose that, okay, we have these 600 farmers. I say, okay, I am one farmer. I assume, so we are in equilibrium. One farmer says that, let's assume that all of the other 599 farmers are fixed at equilibrium. They are robots. They will charge 60 and they will produce 1 unit. What should I do? So I do my maximization problem. Now, it turns out, and this is basically what Steve Keen has written many papers about, that the maximization problem for this one farmer is the same as the maximization problem for the industry as a whole. That is, as I change my W, my production level, the price fluctuates exactly as the price fluctuates for the industry as a whole. Now, if you solve the problem for the industry as a whole, you find that the industry as a whole should not produce 600 because it's a monopolist. 600 is the output in perfect competition. But if you treat all of the 600 farmers as a cooperative and you say they get together and they decide, what should we charge these city people, the city slickers, they are always exploiting us, we should try to get our own. So the village council meets and says, okay, let us make a decision together. Then you find that the total output should be 400 and the price should be 80. That is the profit maximizing price. So now it turns out that if you are at competitive equilibrium, any one farmer has an incentive to raise the price a little bit. Now, and furthermore, as I have said, if he raises the price a little bit, he won't lose the customer, contrary to what the conventional theory says. So now, but if this is true for one farmer, it is true for all farmers. And if all farmers raise the price by about, actually I calculated it is about 2 parts in 1,000 in this situation, they will all make a little bit more profit. But now suppose everybody is now producing, and the total output will go down from 600 to 599. It's only a very small change. But basically, you see, the issue is exactly this, that if you look at what's happening at the level of one farmer, the change is really very, very small, and as the economists say, it can be ignored. But when you multiply it by 600, then this 2 parts in 1,000 multiplied by 600 translates to 1 unit of reduction at the aggregate level. And now if you repeat this process, so next year people say that one farmer raised his price by 1 cent and he made a profit, so let's all raise the price by 1 cent. Now what will happen is that the units of the production will go down by 1 unit and everybody will be charging 1 more cent. Now again, one farmer can say that I will recompute the equilibrium. If he recomputes, he will say that, oh, I can raise the price 1 more cent. And once this process continues, then you will go back to equilibrium. So I'm not saying this is how the world will work, but I'm saying is that it is essential to look at the dynamics of the process. It's essential to look at what happens in disequilibrium, and these approximations that economists make about perfect competition, zero transaction costs, and perfect full information. And this gets rid of expectations. But expectations are crucial. And expectations is how people matter. You see, in the economist's story, people don't matter because there's nothing people can do. Everything is governed by these mechanical forces. But once you take into account the expectations, then people matter. What people do matters, how people behave matters, because they will determine. So if people are all optimistic about the future, they can, and if people are all pessimistic, they can cause bank crashes and crises. This is in fact how the financial crisis happen, when suddenly the expectations change. And if everybody starts to believe that the stock market is going to crash tomorrow, then they will start selling their stocks and it will cause a crash. And nothing needs to change physically. This is how the East Asian crisis happened. There was a crisis in Thailand in baht, and suddenly foreign investors said that, oh, there's some trouble in East Asia, and they started withdrawing money, and they caused the crisis in Singapore and Indonesia and Malaysia when there was nothing wrong with the economy. So these expectations matter. So our models, when we put in expectations, then we will have to ask how expectations are formed. Now this is where the Chicago school put in rational expectations. They said, no, we can't allow any kind of expectations. The expectations have to be right. If the expectations are right, then at least they are anchored in reality. So whatever is going to happen tomorrow, my expectation reflects what is actually going to happen. Now the problem is that this is a sort of circular reasoning, because what happens tomorrow depends on my expectations. So this is something which causes serious problems. So we have this issue that dynamics matters, information structure. So all of those things which we are disregarding in economics. And why are we disregarding? Because we can do the calculations. If that is true, And we cannot do the calculations if there are transaction costs, if there is information structure. This makes things very complicated. Suppose that as in reality we have heterogeneous information. Different people have access to different types of information. How are you going to calculate that? It makes it almost impossible. That's why economists do calculations under assumptions which makes calculation possible. But if we are dealing with the agent-based model, then we can put in all of these constraints, and we can say that, okay, agents don't have information, they have these expectation processes which we have to model, and depending on what the expectations are, these will actually drive the economy. See, if you consider this economy which we are considering about wheat, what the farmer is going to do today depends on how he will forecast the price for tomorrow. This is just, there's no way to get around this. This is absolute. This is true in reality. That is, this is not an artifact of modeling. This is really true that what the farmer decides about what he will be doing today depends on his forecast of what the price will be at harvest time. There's just no way around it. So now the question is, how do farmers forecast prices? So one very simple mechanism is, whatever the price today is, it will be the same tomorrow. And this is actually a good place to start. But that's not always true, and there are many things which make a difference, and people might say that, okay, people might do two levels of thinking, and that often happens, that, okay, today tomatoes are scarce, and I see that everybody is excited about this opportunity, and everybody is going to plant tomatoes, so I realize that even though it seems like a profitable opportunity, everybody is trying to capitalize on this, so I should not plant tomatoes because tomorrow tomatoes will be in surplus. Instead, everybody who was planting potatoes is now switching to tomatoes, so tomorrow potatoes will be scarce, so I should plant potatoes. So these kind of complex real world processes do matter, and so we have to put these in. So maybe we have 90% first round thinkers who just look at what the world is doing today and forecast, and then we have 10% sophisticated thinkers who look at what the other people are doing, and then they make their decisions on that basis. There are many different kinds of models we can make, and different kind of outcomes which will result. And so that is what the agent-based models do. So the reason that the supply and demand models fail is because of this. There are transaction costs, there are information costs, expectations are involved. There is no single marketplace in which there will be one price. So the famous law of one price doesn't hold. What really happens is that you have lots of different buyers and lots of different sellers, and then we have random collisions between buyers and sellers. So when a buyer meets a seller, at that time the price that the seller is charging becomes known to him, and he may know that this is not the best price available. He may have even past experience that the price should be lower, but he can't be bothered to go and search for this price. Sometimes people do search if they have low search costs, sometimes they don't. So this means that if you model, if you say that there is no one market and there are multiple transactions, then immediate consequence is that there will be heterogeneity of pricing. There will not be one price. Now, what corresponds to the reality that we see out there? We see that there is no one market, that the same good sells for multiple prices. So This model, this way of modeling where we have multiple buyers and multiple sellers and they interact and there are multiple transactions at multiple prices. The same good is being sold at the same time for different prices. This is what corresponds to reality. This is what our heterogeneous models can handle. This is what economists cannot handle because they cannot do the calculations required for handling such models. In fact, Duncan Foley started the first models of like this, in which he invoked theories from quantum physics, basically to do the calculations. He says, okay, it's clear that there will not be one price, so there will be a distribution of prices. So what will this distribution be? So it turns out that in quantum physics they have these models in which the particles of gases are interacting with each other, and so there is a distribution of speeds. There is no one speed. All particles are not at one speed. Entropy is driving them in the long run, so that some are moving faster, some are moving slower. When they hit each other, then the faster particle transmits some of its energy to the lower speed particle. So in the end, in the long run equilibrium, all of the particles will be moving at the same speed because the fastest will become slow, the slowers will become fast. So that's the equilibrium. But before you get to equilibrium, so as the same thing in economics, that in long run equilibrium where everything is known, there should be one price, but it's not. It's how you get to equilibrium which matters, and in the process of equilibrium there will be a distribution of prices, and this distribution can be calculated to some extent, and we can calculate it using the quantum mechanics formula, which actually one of my students is currently studying. But we can also calculate it by setting up the agent-based model and just simulating it and letting the computer do the calculations. I was explaining this situation to an engineer that we have a possibility for launching a revolution in economic theory by just using computers to solve. He said, this thing already happened in engineering in the 70s. In the 70s, we used to do calculations about stress of materials and about this and that and the other based on a very limited number of formulas that we knew how to do by hand. And then suddenly, these computer-based methods came along which allowed us to calculate. So you want to calculate how much stress can be handled by a particular material. So there is some theory, physical theory, which allows you to do the calculations. But given our limitations, given that we are using slide rules and calculating formulas by hand, there's only very limited. He says that let's assume that the bar of metal is a perfect circle, then we can do the calculations. Or if it's a perfect square, then we can do the calculations. But if it's irregularly shaped, then the calculations are impossible. But so what they did was they would approximate the irregular shape by a circle, and then they would do the calculations. And this is what economists do. Now when the finite element method, you can feed the irregular shape to the computer and it will produce the answers using numerical methods. So he said that there was a big battle. The old engineers didn't accept the computer results. They said that, if we teach people in this way, they will never develop the intuition, which is true, that there is some elegance and some power to the formulas. So the old engineers who knew the old ways, they resisted the introduction of the new computer-based methods. And exactly this battle is taking place in economics today. The behavioral economists are in the minority. They are trying to get heard and they are making a lot of progress, but they are not part of the mainstream. Colin Cameron, who has written this book, he writes at the end of one chapter, today we are just trying to get acceptability in the profession. It is not their goal to launch a revolution. Because the profession is very powerful. Thousands of students are getting trained in the old methods, and they are getting jobs, and their professors have jobs at all the prestigious universities, so they're not going to allow revolution to take place. So these new methods are going to displace the old methods, and there are some, it is worthwhile. Some intuition is generated by studying the old methods. The formulas give you something which the computer cannot, but the computer gives you something which the formulas cannot. So today when we teach mathematical methods using alpha Chiang, we teach students how to do these matrix inversions by hand, and we teach students how to do maximization problems. We can even teach them calculus of variations, which allows them to maximize. But there are only 2, 3, 4, 5 problems which you can solve by hand. Otherwise, even if you put down some, there is a class of problems which are used in textbooks, and there's thousands of problems which the computer can do just if you set it up and feed it to the computer. So if you want to do maximization, we can sort of revise that course, and we can, instead of teaching people how to solve problems by hand, we can teach people how to set up a problem to feed to the computer. This will involve teaching them entirely different things, but then they will be able to do 1,000 things which Alpha Chiang cannot teach them how to do, and none of the books can teach them, because the things you can do by hand are automatically very limited. Similarly, we can set up very complex economies and ask the computer to solve them. So now the skills involved in setting up an economy to feed the computer, this is not zero. I mean, there's a lot of skill and intelligence and understanding that is needed to create good models to feed to the computer. These are the skills that we need to learn. These skills are not available anywhere. How to build a good model which you can feed to the computer, because we can build models, but the models that are being made by economists are nonsense, because they ignore all of the important things. So how do we build good models? Well, basically a good model should be simple. It should be something that you understand what is. Then when you feed to the computer, you will get some results, and those results will often be very peculiar, wrong, difficult, and mismatching to reality. So then you look at your model and you look at reality and you see that, oh, there's something wrong. My model is making predictions which don't happen in reality. Then you try to see why your model is giving results which don't match. You obviously have missed something about reality. So you examine reality to see what is it. There's something important I have missed. So you see why the model produces results which deviates. You try to find the factor which you have missed, and you try to find the simplest possible factor. You try to make a change which is very easy to make. Instead of, there are 1,000 things you have missed, but you say, I want to make this model match reality. What is the one thing that I need to do in order to make this result closer to reality? That way you start with a simple model and you make it gradually more complicated, take into account things in reality which are happening, which your model fails to predict. And that way you build a model. You start by understanding a model, and you build by understanding more complicated models. So as you build models, your understanding improves. Now the way the economists do it, the more complicated model they make, the less you understand. So it's exactly the opposite of what models are supposed to be doing. Models are supposed to be your mental models which help you understand complicated reality. Instead, economists' model make it more difficult to understand reality. So, I will conclude by saying that basically equilibrium is an illusion. The equilibrium illusion was created by economists because that is the only thing they can calculate. You see, if you say what happens in this equilibrium, you can't calculate what it is, but you can feed it to the computer. And now, actually, at the time the theory was invented, physics was Newtonian, and in Newtonian physics you had equilibrium. Later on, physics changed, but the economists haven't caught up, and now the theory of dynamical systems, which studies the behavior of systems, shows that equilibrium doesn't give you much information about the system, because often you have multiple equilibrium in a system, and this is also true of economic system when you have backward bending supply curves for labor and many other situations where you see you have this re-switching, which means that the price of capital can be in two different places for equilibrium. So then there are multiple equilibriums, and so then what economists do is they have this so-called choice of equilibrium. Which of these equilibrium will be chosen in economy? This is the wrong question to ask. It is not. You see, when you have multiple equilibrium, then the system normally doesn't. First of all, any equilibrium can be of three types. They can be attractors, which means that in a dynamical system, locally, if you are near the equilibrium, you will be pulled into that equilibrium. But you can have repellers, so that if you are at equilibrium, that's fine, but if you are slightly away, you will move further away. The example of this is like if you have a hill, which is and there is a ball sitting right on top of that hill. So as long as it's sitting right, it's perfectly balanced, it's in equilibrium, but you touch it just a little, and it will no longer go back to the top of the hill. It will go down. And there's one thing. This is called something. It is called Catastrophe Theory. It's a very strange name. It's also called the butterfly dynamics, the butterfly effect. The butterfly effect is that if you have a set of differential equations and you make a very small change in the initial conditions, you change the starting place of the system by 0.0000000001, then the long run outcome changes by drastically. So the butterfly effect is called that the butterfly flaps its wings in Japan, and 6 months later there is a storm in Brazil. So if the butterfly had just stayed at peace, there would have been no storm. So this kind of thing can happen when you have this is also called a catastrophe, this kind of thing can happen, and this is exactly explained by this ball sitting on top of the hill. If you push it just a little bit, if the butterfly flaps its wings on one side, the ball will go, and suppose there are two villages on either side at the bottom of the hill, then one of the villages will be destroyed, or the other village will be destroyed, just by the flapping of the wing of the butterfly on different sides. So a very small initial effect can translate to a huge later effect. So what this means is that the idea, you see, the economists, that approximately, see, this is another insight, that the economists made their calculations on the assumption that everybody is doing perfect maximization. Now it turns out that if instead of perfect maximization you do approximate maximization, you don't go to the exact calculate maximum, you go within epsilon of the maximum. then everything changes. So there is a whole literature which is called menu costs. So the issue is that, the restaurants, they have these fixed prices for their menus. Now the price of chicken fluctuates every day, but the roast chicken you buy at Kabul restaurant, it has the same price for many months. So where is this price equals marginal cost? So the answer is that, every time you change the price, you have to print the menu. Well, this is not the right answer. The right answer has to do more with what the customers think is fair, and it has to do with expectations. It has to do with a lot of other things. But anyway, the point is that if you are approximately maximizing, then the whole economic theory is drastically affected. So none of these things can be taken into account in the conventional theory, but if we study, there now exist alternatives, and basically complex systems theory. See, if you have the dynamic systems, they show you that you can have equilibria which are either attractors or repellers, or there is the third type, which is that you do cycles around the equilibria. And then if you have multiple equilibria, then again all of them can be attractors, repellers, or stable. And then how the system behaves, it might cycle between two equilibria. So basically, but how do you know? Everything depends on disequilibrium. How does the system behave when it is in disequilibrium? So the issue is, what happens? So if we want to study supply and demand models, we ask, what happens when the price is not in equilibrium? How do people behave? So now the economists are not allowed to think about this question, because they say that we assume the system is always in equilibrium. See, if you look at Varian, he starts by saying that there are two fundamental assumptions. One is optimization, everybody always optimizes, and equilibrium, that systems are always in equilibrium. He says, yeah, true, people might be in disequilibrium, but that's short run, we won't worry about that. So the thing is that everything depends on whether or not you get to equilibrium, depends on what happens in disequilibrium. So unless you study what happens in disequilibrium, you cannot decide whether you are going to get to equilibrium or not. And so now what happens in disequilibrium? This is something which economists don't know. And so we have to think about what happens, and we can think about it by looking at the real world. So the most important thing to understand is that there is a nice cartoon which if I had. This man, the student asked the teacher, what is the meaning of genuflect, for example. So the teacher asked, does anybody know? So students say, no, we don't know. So he says, oh, then it's easy to answer. So there is this cartoon in which the economist is teaching his students macro models, and he's saying that, okay, in the end I will teach you this mantra. You have to repeat this. And this is, so everybody is chanting, nobody knows, nobody knows, nobody knows. So as long as nobody knows, you can tell them anything, any kind of garbage. So since the economists don't know anything about how the real world works, as was demonstrated to everybody, this is what there is a book called The Naked Emperor, that the emperor is naked. As long as we all pretend that he has clothes, then it is respectable. But if we understand that there are no clothes, then it is not very respectable. So now the economists don't know anything about how the real world works. So that means that we are free, but it doesn't mean that we understand the real world works, how the real world works, but we have some intuition. We can use this intuition and we can learn, we can look at the data. Data is available and there's lots of wrong theories, but the theories we can ignore, but the data there is relevant and valuable, and we can pick that up and we can say, okay, this is what the data shows. From this data we can develop a hypothesis, a theory about how the world works, and then we can build it into a model. This model will be much more complicated than the type of models that economists are using, because the simple models don't predict reality. And so what we do is we try to make the simplest possible model which can explain what we see out there. And these simplest models will be more complicated than we can solve by hand, but they won't be more complicated than what the computer can solve. So basically, the strategy to use for modeling is to use agent-based heterogeneous models in which different kinds of expectation processes have to be modeled. So there's a lot of things that you need to know about the real world in order to construct a good model. These things are often not known, so you will have to start. But you start from zero and you build a model, and then you compare the results of your model to reality. And if you find a mismatch, then you fix your model. So this is basically the process. And the two principles that variance says are at the heart of economics: optimization. It never works because you don't have enough information to optimize. And equilibrium, it's not valid because the system is never in equilibrium. So the things that we need to do in order to construct a new economics are open. Nothing has been done. It's a brand new field, fresh place to start. Lots of people are working on these models, but people are at beginning stages. So, see, the basic idea of economic students, which is very true, is that if you want to contribute to modern economic theory, it's a hopeless cause, because the amount of work that you have to study for 4 years to get the mathematics required to build a model of the type that is currently used, and people have done all sorts of things. And the last word is that you get only published if you know the editors, because in the top 20 journals, that's a very exclusive club. And if you have a degree from the top 20 universities, then you can get in. Otherwise, since it's all garbage anyway, they only select their own friends to publish, and otherwise they dismiss it as garbage. And it is so. There is no way for us to contribute to the literature which is in conventional economic theory, and it's a hopeless cause. And so if you work on an orthodox thesis, then basically you are confined to this model which is currently used. You take a paper from the latest issue of American Economic Review, and you replace the data with Pakistani data, and you replace the equations with Pakistani equations, and then you publish your thesis, and that makes for a PhD thesis. But here, if you use the methods that I'm teaching, you can do genuine thinking and genuine research and do a genuine thesis which will have genuine implications about the real world. There is lots of work to be done, but it involves working in ways that are not familiar to economists. You have to go and study history, you have to go and study what's really happening. There is room for data, and there is room for even regression analysis, but these are small parts of the task that needs to be done. A lot more attention has to be paid to real world history and real world, what is really happening at the state bank, what do they really do, how does it really matter. All of these things which are not discussed in the textbooks, these are the things that you need to learn. So at the same time, you have to maintain some continuity with the the field, and you can't go around to your PhD thesis defense and say everything that you have all learned is wrong. Otherwise they won't let you get away with it. So you say everything you have said is right, but there is something more that can be added. And if we add some historical information, doesn't that make it even more interesting? So basically, sometimes I say, okay, do all your analysis, then add some, throw in a regression, because we know how to run regressions to prove anything. So once you have got your results, then you can get data to create a regression which matches your results to convince those people who won't be convinced by any other thing. So there is lots of room now actually, and using agent-based models. Basically the whole goal of the thesis, the way rhetoric of economics is work is that you have to impress the people so much that they are afraid to ask you questions. So now when you use heterogeneous agent-based modeling using complex dynamical systems with Werner's equilibrium and calibration, then people will say, okay, that's good enough. You have your thesis. I don't want to read what you have written. So you have to learn some of the terms that will impress people. You can say I have put in the Durbin-Watson statistic in here also. All right, so hopefully we will have, I'm trying to prepare a suitable course for next semester to where we